true stress and true strain. True stress and true strain. Until this, whatever we have discussed about stress and strain, that is called engineering stress and strain. Whatever we have discussed, that was engineering stress and strain. That is sigma and epsilon. That is called engineering stress and strain. What was the criteria to determine engineering stress and strain? We have considered initial length and cross-sectional area. That is, say L0 and A0. We have determined stress by what? That is P by A0 actually. That is what is the initial area of the component. That gives us the stress. But whenever a component is subjected to stress or force, it's at any instant its area is not equal to the initial area. Area cross sectional area is also changing. Similarly, we have determined strain by what? Delta L by L0, and that gives erroneous result when the component undergoes large deformation. So for large deformation, engineering stress strain gives erroneous result. As we calculate them from initial length and initial cross-sectional area, but at a particular instant the area and length is not equal to the initial value. So for small deformation, engineering stress strain gives the error is very less. That is, engineering stress strain is valid for small deformation, but whenever there is a large deformation, that gives erroneous result. Then what we have to calculate? We have to go for true stress strain for large deformation. Now what is true stress? Let us come to here. True stress. What is true stress? P by A. A is the instantaneous area of the component. A is instantaneous cross-sectional area of the component. So what we can write from this? A0 is the initial area into A0 by A. That is P by A0 is engineering stress, and A0 by A is nothing but L by L0. That is, we are considering that volume of the component remains constant. That is, A0 L0 is AL. That is, A0 by A is L by L0. That is, we can write sigma L0 plus delta L by L0, and that is nothing but sigma 1 plus, and delta L by L0 is nothing but engineering strength. That is, the expression of true stress is engineering stress into 1 plus engineering strain. So this is the expression of true stress. Now, what is true strain? True strain. The elemental true strain, that is elemental true strain is epsilon t, that is dl by L. L is instantaneous length, that is length at any instant, similar like A, that is epsilon t is integration 0 to dl by L, that is what ln L to L0 to L, that is ln L by L0, that is ln L L0 delta L by L0, that is equal to ln 1 plus epsilon. So true strain is ln 1 plus engineering strain. So this is the expression of true strain. Now let me show you that engineering stress and strain gives, or engineering strain gives erroneous result when there is a large deformation. By this example, so this is the initial length of the component. Now it has been elongated to 2L, from L to 2L, and further it is compressed to L. So there are two stage operation. Now let us calculate what is resultant engineering strain and resultant engineering stress. So what is total engineering strain? That is, say this is operation 1 and this is operation 2. Epsilon 1 plus epsilon 2. What is epsilon 1? Epsilon 1 is delta L is L and L0 is also L. So L by L plus. What is compression here? Minus L. So that will be minus L. And initial length is 2L. That is 1 minus 0.5. That is equal to 0.5. That is total engineering strain is 0.5. But it has, the total strain is 0 actually. But engineering strain gives that total strain is 0.5 because this is the initial length and this is the final length. They are same, but engineering strain gives the incorrect value, that is 0.5. Now let us calculate the resultant true strain, that is T1 plus epsilon T2, that is ln. What is final length? That is 2L. What is initial length? L plus ln. What is final length for process 2? That is L. Initial length is 2L. That is ln 2 plus ln half. That is ln 2 minus ln 2. That is 0. So that gives the correct answer because there is no strain, no resultant strain, because initial length and final length are same and the summation of engineering strain is 0. This is the correct. So this is correct. This is incorrect. So for large deformation, engineering stress and strain gives erroneous result, whereas true strain gives the perfect result. So with this, we are ending our session here. Thank you.